Okay, Math 2, Unit 3, Worksheet 3D, Parallel Lines. Starting with number 2, given BA is congruent, or excuse me, BA is parallel to CD. One thing missing on number 2 that some of you may have struggled with, you also need to know that BC is parallel to AD. Now you can complete that. Without that little piece of information, you can't really solve this proof. All right, so going through, let's add this. BC is parallel to AD. That's given. All right, now this is where you should have stopped because you can't state this. Let's see, ABD is congruent to CDB. We can do that one because alternate interior angles, because these two lines were parallel, that was given. But this guy, without the piece of information I just added, you shouldn't have been able to do. But most of you probably didn't pick up on that. But now that we know these two lines are parallel, CBD and ADB are also congruent by alternate interior angles, or alternate interior angle theorem. BD is congruent to BD by reflexive property. And we know that ABD is congruent to CDB by angle-side angle postulate. Angle-side angle. Okay, moving on. Number 3, BE is parallel to CD, and AE is parallel to BD. Okay? B is the midpoint of AC. So, given, I'm going to write all this given down here. BE is parallel to CD. AE is parallel to BD. And B, midpoint of AC. That's all given. We know those guys are parallel. Add the two arrows there. We know that AB is congruent to BC because of midpoint. So if these two guys are parallel, all right, we have these two guys are parallel and they're cut by AC, then we know those two are congruent by corresponding angles. If these two guys are parallel and they're cut by AC, we know that actually these two guys are parallel. So now by angle, side angle, angle, side angle, we know the two triangles are congruent. We just have to write it up. So first, I'll go with, let's do with angle EAB. Did I do this one with you guys? Okay, but I guess I didn't do it with everybody, so let's just go over that real quick. Let's see, is congruent to angle DBC, and we know that because of corresponding angles are congruent, and we know the same about angle ABE. ABE is congruent to angle BCD, and it's the same thing, corresponding angles are congruent. And finally, line segment AB is congruent to line segment BC because of definition of midpoint. And now we have all the three parts mentioned, so we can say that triangle, what is that? EBA is congruent to triangle, let's see, EBA, so it's DCB by angle side angle postulate. Okay, moving on. We've got BE is parallel to CD, so we'll put that, which means that these two angles, let's see here, these two angles are going to be congruent by corresponding angles. AC, let's see, B is the midpoint of AC, so we know these two guys are congruent. And BE is congruent to CD. So by side angle side, we know these two triangles are congruent. So I'm going to write up BE is parallel to CD. B is the midpoint of AC. And BE is congruent to CD. All right, that's given. All right. So we know this is one of our statements. We're going side angle side. That's one of our statements right there. So let's write up the angle now. So we're going to say that angle ABE is congruent to angle BCD. And we know that because of corresponding angles. When lines are parallel, corresponding angles are congruent. So I'm going to write corresponding angles are congruent. And then we're going to put AB, line segment AB is congruent to line segment BC. That is definition of midpoint. B is the midpoint of AC. So by definition, they are congruent. And finally, we can say that triangle ABE is congruent to triangle, okay, ABE, so it has to be triangle BCD. And we know that by side angle side. Okay, how are we doing? Am I going too fast? All right, let's do this one here. Fix the errors. Let's see what we got going. So we know that, excuse me, we know that angle C is congruent to angle D. All right, that's given. Angle A is congruent to angle B. We don't know that to be true. Alternate interior angles are congruent. So if we're going to say that A is congruent to B, we have to add that AC is parallel to DB. So we have to add that to our given. So we can go AC is parallel to DB. That would fix, if we add that and we put it here, now AB is a transversal, so now we could say that angle B is congruent to angle A. That fixes that. Let's see. All right, next we have angle AEC is congruent to angle BED. Vertical angles, that's true, but that doesn't help us, does it? Okay, we would need to know something. So if we wanted to fix this, one thing we could do that would be real easy is we could cross this off. And we could say, I guess we could say we'd have to add it to the given. Let's make it easy for us. Let's just say that DB is congruent to AC, and we just have to add that to the given, I guess. And then we could say by angle side angle is congruent to angle side angle. And then you'd have to change that to angle side angle. Okay, so that one's got a lot of errors. You might have just pointed out all the errors and not fixed them. Okay, moving on. All right, so F, I did number 1 correct, that's it?
Yeah.
So moving on to number 2. All right, so this one is about perpendicular lines. So let's see what we got. We got BD is parallel or perpendicular to AC. If BD is perpendicular to AC, it tells us that all 4 of these angles are right angles. And AC bisects, let's see, BD bisects AC, which tells us that AE and EC are congruent. And we also know that AB is congruent to CD. All right. So right triangle, so right away I look and see if HL will work. And if you look at these two triangles, call that triangle 1 and triangle 2, They're both right triangles. They both have a leg that's congruent, and they both have congruent hypotenuses. So we can do this. So all of this is given. Okay. We know that angle AEB and angle CED are right angles. Check. That was in the given. So that is definition of perpendicular lines. You always look to the previous step for your reason. How do we know these are right angles? Well, because we were told they're perpendicular lines. So definition of perpendicular lines. AE is congruent to EC. How do we know that? Definition of bisector. See, we look to the given for that. And finally, we have AEB is congruent to CED, and we did that by hypotenuse leg. Here is the hypotenuse. No, here's the hypotenuse. Here's the leg. All right, moving on. Number 3. Given AC is perpendicular to CB, and AD is perpendicular to DB, and AE is congruent to BE. All right, so what does that mean? AC is congruent to, or perpendicular to CB, so that's a right angle. And AD is perpendicular to BD, which means that's a right angle. And we also know that AE is congruent to BE. All right, I'm thinking hypotenuse leg here. We got a right triangle. We know the hypotenuses are congruent. Unfortunately, we don't know anything about CE and DE, and we don't know anything about AC and BD. So hypotenuse leg is not going to work. What do we know? We know vertical angles. Did I do this one with you guys? Okay, I thought I did that one. Maybe not this group. All right, either way, we know vertical angles, so let's write it up. So first off, we got AE is congruent to BE. That is given right there. That's our side. We're going to do angle, angle, side, and that's our side. It's already in the given. Next, we're going to say that angle ACE is congruent to angle BDE. Okay? And we're going to say no, actually I'm going to change this. We're going to have to say that basically angle ACE and angle BDE are right angles. And then we're going to put definition of perpendicular lines. Oops. And then we're going to put ACE. If you didn't put this, it's okay. ACE is congruent to BDE. And then we'll put definition of right angles. So we had to say that these two guys were right angles from the definition of them being perpendicular lines. Then we could say they are congruent by definition of right angles. It's kind of too far to go, hey, these guys are perpendicular lines, so therefore the two angles are congruent. So if you didn't add that, it's not that big a deal. I'm sure one of these will not be on your test. All right, in proofs you have to be very specific. Okay, so now we've got one of our angles. Now we just need to say that angle AEC is congruent to angle BED, and that is definition of vertical angles. Or I would accept vertical angles are congruent. That's perfectly okay. We've marked our two angles, so now we can say that triangle BDE is congruent to triangle, let's see, BED, no, I'm sorry, BDE. BDE, so it's got to go ACE. And that is by angle, angle, side postulate. How we doing? Okay, last one. All right, so all your given goes right here. I'm not going to rewrite it because I'm trying to hurry. But E is the midpoint of DC, so that means those two guys are congruent. DB is perpendicular to DC, so that's a right triangle, a right angle. And AC is perpendicular to DC, so that's a right triangle. Again, we got one leg each. It would be great if we knew something about the hypotenuses, but we don't. So we can't use hypotenuse leg. So we can always rely on vertical angles, right? So it looks like by angle, side, angle, we can say these two triangles are congruent. What two triangles? Well, let's see. If we're doing ECA, we would have to go EDB. And we're going to go by angle, side, angle. All right, so you would rewrite all the given in here, and that's a given. Notice there's no equality or no congruency statements. So we have to write all three of those up. Let's start with the right angle. So let's say that, first we'll say that angle EDB and angle ECA are right angles. And I'm going to take a little shortcut here, right angles. And that is definition of perpendicular lines. Is everybody with me on this? Okay, so now that we've stated that they're right angles, we can say that they're congruent. All right angles are congruent, right? So we'll say angle EDB is congruent to angle ECA, and we just put definition of right angles. Do you understand how in a proof you have to use the previous steps to make your next step true? These guys are perpendicular lines, therefore we can say these two angles are right angles, therefore we can say these two angles are congruent. Everything has to be proved. So there's our first angle. All right, now we're going to say that line segment DE is congruent to line segment CE, and that we know because of E is the midpoint. So we'll say definition of midpoint. So now we have our side proven. And finally we can state that angle, where are we? DEB, angle DEB is congruent to angle CEA, and that is definition of vertical angles, or you could say vertical angles are congruent. Sorry here guys, vertical angles are congruent. It happens when I hurry. Okay? And finally now we've got all three statements. 1, 2, 3. We can say that triangle AEC is congruent to triangle EDB by angle, side, angle postulate. Okay, what do you think? Good? How are we doing on these? Not so good? I don't see happy faces. 1, 2, 3, 4. What are you? Have we done this before in here?